Hey everybody, what is going on? Today we're going to be talking about interpreting graphs. Alright, so these are not graphs like histograms, bar graphs, pie charts, and things like that. That's another video I could do for you if I haven't done so already. This is more along the lines of direct variation, where you have y equals kx, something that we're going to talk about in the video. If you're going to do a cross-curricular approach to this, you see a lot of this with physics. We're dealing with the first quadrant, so you may want to watch my video on coordinate plane if you're not familiar with this. It's a pretty fun subject to teach. The kids seem to have a good time with this because it's very literal. There actually isn't a lot of math involved. It actually is exactly what it sounds like. It's interpreting lines in a graph and stories. So I hope you have a good time with it. I hope it's very helpful for you. You may want to watch the video a couple times, but please also subscribe, comment, share it out. I hope it's very useful for you. Okay, with these direct variation types of problems, what we need to do is make sure that we have our labels, all right? A lot of times, it's usually something versus time, all right, since it's a story. So let's take a read through here. An elevator was on the 10th floor of an office building. It came down and stopped at the 4th floor. It continued down, stopping at each of the remaining floors until it reached the 1st floor. Graph the story. All right, so for our x-axis, we want to do that, set that up for time, because this is over the course of a time, all right? So what you need to know is that this is not a literal type of drawing. It's basically showing you what is taking place over time, all right? Well, we're dealing with the height of the elevator, okay, over time. So we're just doing it based off of what's in the story. We need to be clear on that. So it says an elevator was on the 10th floor of the office building. That's our first sentence. So it doesn't have to be completely accurate, but we know that it's going to be up here somewhere. If you want to write a 10 there, you can. It came down and stopped at the 4th floor. So over time, right, it's continuing to move in a downward direction, stopping at the 4th floor, which really would be more or less halfway, all right? This is where you got to be careful. It came down and stopped at the 4th floor. Well, it stopped, but time still passes on, meaning that we're going to have a horizontal line here indicating that it's stopping maybe to pick up people, let people off. Then it continued down, stopping at each of the remaining floors. Well, if this is for 4th floor, goes down, stops at the 3rd floor, waits for people, goes down, stops at the 2nd floor, wait for people, and then continues all the way down to the 1st floor. All right, so your graph should look like that. If you're having issues with this, replay that part of the video. It can get a little tricky, but I need to state that any time that you have something over here, no matter what it is, in this case it's height versus time, these horizontal lines indicate that there's a stoppage, not of time, but there's waiting taking place. Okay, for this particular problem, they want us to write a story that describes the graph. So this is talking about a skier, right, in terms of elevation and a ski slope. All right, so we look at our given axes here. We have that the x-axis once again represents time, where this is the elevation of the skier. So there's a couple different ways you could go here. So if we're at the top, we know that his elevation has to be pretty high. So we can say the skier started at the top of a run. Started at the top of a ski run. All right, so that indicates this point. And then he or she travels downward. They ski down. Right, that was that part. And then right here, they're waiting for the ski lift. All right, then obviously they're going back upward. So the vertical line going now, or the horizontal line going upward, would be going upward on the ski lift, taking ski lift up. And then you can see that the pattern repeats. Skis down, waits for lift, goes back up. And that's pretty much what skiing is. Okay? So something to that effect would be appropriate for this graph interpretation.